So, for example, Tycho here, large, relatively young crater on the surface of the Moon. This is what it looks like with the Lunar Reconnaissance Orbiter, LRO, and you can see it's got that rebound peak in the middle. It's a large crater. If you have a small crater, it kind of holds together. If you have one over 10 kilometres, the crater rims sort of slump a bit under gravity and kind of sag and don't stay as sharp. And you can see that beginning to happening around the edge of Tycho. But if we zoom in right to this peak here, this is a view of that central peak. Good. Glad you like that. Haven't finished yet. Can you see there's a little white dot just there? Okay. You can zoom in right to that. See, it's a boulder about 100 metres across. Here's another view of it. This is the kind of detail. They're mapping features down to like half a metre across. But this is of interest because this is part of the ejecta from that impact that created Tycho. It tells you how quick that mountain forms in the centre. Is in the creation of this crater where you've got the compression wave, rarefaction throws stuff out, rebound creates peak, ejecta lands back on peak. That mountain formed very quickly. And you can see also some impact melt deposit here as well, of stuff that was molten and then frozen back on top of that mountain. Here's Kepler, another large crater. You can see the walls of it are also slumping a bit under gravity. From LRO, if you look at the walls of this crater, now just to orient you, this is the crater floor, this is the wall of the crater. You can see bedrock. You can see the outer bedrock of the Moon, and loose stuff is undercutting and falling down the sides and landing on the crater floor where there are all these boulders. So the Moon is being shaken by tiny seismic quakes. These are created by the tidal pull of the Earth, and also the shakes from other impact activity. And this just breaks any loose light moon dust off to roll down the surface, and gradually this bedrock's being undermined, and every so often a big boulder might crash down to the floor of the crater. So we can map things like that are happening, and you can actually look at these boulders and the trails they leave. So this is a different crater, this is Menelaus, but here's the floor. You can see the bounce trails of the boulders to where they come rest as they fall down the slope. And the spacing of those bounces tells you a lot about the mass of the rock, how quickly it travelled down, and also by tracking the marks back up, you can work out where it fell from. And so you can tell something about, by examining these boulders, you can tell something about the bedrock further up the cliff face. And of course, sometimes you can see what stops them.